Hey guys, so now you've learned about the scientific method and you think you're ready to experiment. We're going to start off today's lecture with one of my infamous, because they're not that good, cartoon drawings. Right, so we have a student going, let's experiment, science is great, so much fun. We have someone else going, wait, do you even know what an experiment is? So, do you know what an experiment is? That's what we're going to answer today. An experiment is designed to test a hypothesis. Remember that hypothesis is a question that we have and what we think is going to happen. If this happens, then this will happen. Well, once you come up with that, you have to test it. Is that going to happen? Is that what really happens there? So, you do an experiment. Now, there's lots of things that experiments aren't, and we're going to talk about that. But we're going to talk about the things that make something an experiment. And we need to be very careful how we use that word in science class. And if you catch me using it wrong, let me know. Because we do lots of things. Some of them are experiments, some of them are other things. For it to be an experiment, it has to be a fair test. Wouldn't it be fair if I came in and gave somebody a test on 100 science words that were really hard, and somebody a test on 3 science words that were really easy? Is that fair? No! When we test our hypothesis, we have to make sure that the conditions are fair. We are changing one thing, and only one thing. We're measuring and observing something, and everything else stays the same. So we change one thing, we measure or observe something, everything stays the same. One way to help us remember that is cows moo softly. Aren't you glad I didn't draw a cow after that last drawing? Right, so it helps us remember. Cows, we change one thing. Moo, we measure or observe. And softly, same for everything else. Now, I'm sure scientists in the lab don't go, hey Dan, did you remember cows moo softly? No, they have a little bit of different words. So we're going to talk about what scientists say. And we're going to try to speak like a scientist in science class. When scientists talk about their experiments, they call the one thing that they change the independent variable. So that one change is the independent variable. They call what they measure or observe the dependent variable. It depends on something. And they say that everything else is a constant or is at constant. It stays the same. Okay? If your little sister is constantly talking, she's always doing it, it's the same, constant. All right, let's see if I can flip these boards now. Well, I might get it this time. Ta-da! Got it. For it to be an experiment, you must have one and only one independent variable. One way to help remember that is I change. Your independent variable is what you as the experimenter change. Independent, I change. It's okay to look silly. When we move our bodies like that, it helps our brain make deeper connections. So for an experiment to be correct, it needs to have only one independent variable. I change one thing in my experiment. You must measure something. This is your dependent variable. It depends on what you do. I change the independent variable. The experiment changes the dependent variable. It depends on what happens. And everything else remains the same or constant. Just like your little sister who's constantly talking, remains the same. Always the same thing happening there. All right, so let's go ahead and look at an experiment. All right, so the purpose of this experiment is how much water do my tomato plants need? I'm going to change one thing. I change independent variable. How much I'm going to water it. I'll water some 1 liter a day, some 2 liters a day, some 3 liters a day. Then I'm going to measure something or observe. How many centimeters does each plant grow? I'm going to get out a meter stick. I'm going to measure this. My first plant didn't grow at all, 0 centimeters. My second plant, 5 centimeters. My last plant, 20 centimeters. Same for everything else. So they're all growing on the same structure, planted the same kind of seeds, gave them the same, so we have the same planters, the same sunlight, the same soil, the same nutrients. The only thing that changes is that one thing, independent variable. So I either get 1 liter, 2 liters, or 3 liters of water. And one last quick review about an experiment. Experiments have a hypothesis. They have procedures. You're going step by step. You have one independent variable, independent I change, and you have one dependent variable. That's what the experiment changes. It depends on what's happening. It's what you're going to measure. And you have a constant. The constant stays the same. You're collecting data. When you do that measuring piece with the dependent variable, you're writing down bits of information. That's your data. And finally, you have a conclusion. You learn something. You can go, oh yeah, the hypothesis was totally right on, or I don't really know about the hypothesis. Maybe let's try something else next time. So we talked about what an experiment is. Let's talk about what an experiment is not. And that doesn't mean these are things we can't do in class. This means these are things we're not going to do for science fair. We're not going to call them an experiment. So whenever you make a model, like a volcano model or a solar system model, you're modeling things that happen. In class, we have an atom model. Models are great. They show us small things bigger, or they show big things smaller. So if I do a model of the solar system, I'm taking something that's big and making it small so we can see it in class. We'll do that this year. It's really pretty fun. Maybe Miss Kirshner will be around to help us out with it. If I'm doing a model of an atom, I'm taking something that's tiny and I can't even see it, and I'm making it big so we can talk about it and manipulate it. So models are great. Scientists use them all the time. A model on its own, though, is not an experiment. If we're doing nature scavenger hunts, we're observing, we're making observations, we're taking some evidence maybe. Not really a science experiment, though. Research reports, you're going to be doing these. You're going to be finding something, researching it, learning about it, maybe writing a report. That can be part of an experiment, but the report itself is not an experiment. And science demonstrations. There'll be a lot of things that I show you, or that maybe we have someone in class show us, but if we're not changing something and measuring something and leaving everything else the same, then we're not experimenting. If I'm just showing you, hey guys, look at this really cool reaction, is that an experiment? No. Hey guys, what do you think if I gave this one 20 milliliters and that one 30 milliliters and this one 50 milliliters, which reaction would be the biggest? Could that be taken into an experiment? Definitely. We could amp that up and make that an experiment. But just remember, models, reports, demonstrations, these are not experiments. We need to have all of these pieces for it to be an experiment. All right, so that's all we have for today. I'll talk to you guys in science class.